DeepSeas is a comprehensive tool designed to streamline the development of complex mechatronic systems. It consolidates key aspects of the development process into a single integrated platform. These aspects are conceptualization, specification, architecture design, expenses estimation, task scheduling, and eco-impact assessment. For this time, we will only focus on designing the system architecture while simultaneously assessing the environmental impact, especially in terms of global warming. In general, building a product comprises 5 phases: raw material extraction and refining, manufacturing and processing, usage, waste disposal, and transportation and distribution. Product to build the product requires electric energy source, fuel, natural resources, and this operation may result in water pollution, soil degradation, and atmospheric greenhouse gases emission. For this time, we'll only focus on greenhouse gases responsible for global warming. Depending on the phases of interest or availability of data, one can opt to include or exclude specific phases. This results in either a partial or complete life cycle assessment of a product. The different models of life cycle are gate-to-gate, which is a partial life cycle assessment looking at only one value-added process in the entire production chain. The cradle-to-gate, which is a partial life cycle from the source extraction to the factory gate before it is transported to the consumer. Gate-to-grave, which is also a partial life cycle assessment from the delivery of the product to the consumer to its disposal. Grave being the disposal of the product. Cradle-to-grave covers the entire life cycle of the product. It is a full analysis of a product from the raw material extraction to the disposal of the product in an attempt to determine its full environmental impact. And cradle to cradle, which is a special kind of cradle to grave assessment where the end of life disposal step for the product is a recycling process. We've defined what we want to assess. Now let's take a look at who we want to assess. Identifying the phases to be assessed for global warming impact is not enough. It is essential to establish the connection between this emission and the companies responsible for the emission if one intends to effectively reduce them. To achieve this, it is essential to understand the following concept. Businesses rely on their supply chains for the delivery of products and services. The final business delivering a product or a service is not solely responsible for greenhouse gas emission throughout the product life cycle. Allocating emissions among all participants in the supply chain is essential. The allocation improves transparency and accountability regarding environmental and health impact. To allocate emissions among all participants, we use the notion of emission scopes. Emission scopes ensure responsible environmental management. Each scope is made of categories. Let's take a look at those scopes and the categories that make them. Scope 1. Scope 1 is made of the direct green gas emissions that occur from the source that are owned and controlled by the company. It is made of 4 categories. Scope 2 is made of indirect greenhouse gas emission from the generation of purchased energy from utility provider. It is made of 2 categories. Scope 3 upstream is made of indirect greenhouse gas emissions that occur in the value chain of the company before its own operations begin. It is made of 8 categories. And the Scope 3 downstream, which is indirect green gas emission that occur after the company has sold its product for or service. It is made of 7 categories. For this time, we will overlook the Scope 3 downstream, too complex for this overview. For the Scope 3 upstream, we will take a particular interest in the first category, the purchased goods and services, which refer to emission from the production of goods and services that the organization buys. In other words, this represents the carbon footprint inherited by purchasing product from third parties company. Let's understand it with an example. To comprehend the concept of carbon footprint responsibility within a supply chain, let's consider the automotive sector, which comprises 3 tiers of suppliers. This structure illustrates how the carbon footprint propagates through each tier, ultimately reaching the OEM. Emission scopes are determined by the reporting company. Tier 3 Scope 2 emission differ from Tier 1 Scope 2 emission, and vice versa. Tier 1 is supplied by Tier 2, which is supplied by Tier 3. Scope 3 upstream emission, along with Scope 1 and Scope 2 emission of lower tiers, become Scope 3 upstream emission in the category purchased goods and services of the upper layer. Let's take a concrete example to better understand it. Let's say that the Tier 3 is producing silicon wafers with a global warming impact of 100 kilograms of CO2 equivalent. The wafer is going to be used to produce power module, so the 100 become the Scope 3 upstream of the power module. To produce the power module, additional activities are conducted and the use of electricity, which add additional 25 kilograms of CO2, and the complete impact of producing the power module becomes the sum of what was done with the silicon wafer and the activity for the power module, which results in 125 kilograms of CO2 equivalent. The reasoning continues for creating the inverter, which uses the power module, and the car, which is going to utilize the inverter. Thanks to this DeepSys, the estimation of global warming impact of complex system is made easy. DeepSys takes the advantage of the structure of the product spread through its architecture to estimate the global warming impact. Here the example to illustrate how it works in DeepSys. So we are going to build a black box that represents a system to acquire current. It is made of an electromagnetic system to measure the current, an electronic board for the signal conditioning, an interface to convert analog to digital the measurement, and a software to rescale to the value that was measured and verify that there is no mistake or no anomaly in the measurement that are made. The rescaling and the detection of faults have produced some CO2 due to the development phase, and everything was reported to the block comprising them, which also includes some integration steps that add some carbon footprint to the result. The same is done for the other element, and everything is reported back to the current acquisition system. So we're going to build this system in DeepSys and see how easy it can be made.
Build our system. First, our black box, the current acquisition system. It is made of the electronic to measure, the electronic for the conditioning, the interface, and the software solution. Let's rename all these elements. We are in the architecture perspective, so we can click on the element and drop all its components inside the canvas. We're going to split them just so that we can look at them. We don't really care on how they are connected, just to show one connection. But the most important here is to see that when I'm hovering over an element, I can see that the carbon footprint is at 0. Inside, I will double click on the software component to include the 2 subcomponents inside it. 1 and 2. Going to rename them the same way. And as we can see, carbon footprint 0, carbon footprint 0, and if we go back to the upper layer, everything is 0. So now let's go to the eco footprint aspect. And we can see that here, nothing is produced. So let's start making the modification. So we are going to start with those elements here. We talk about scope 1 and 2, but just let's modify one of them and put all the value here. And because we have some modification here, we can see that in the upper layer, now we directly have something expressed in its composition. And looking at the scope 3, we can see that the purchased goods and surfaces already account for the value that we express here. It's supposed to be in kilogram of CO2 equivalent, but here's just in gram, just so that we have an idea of that. Let's try to modify all the additional element here. I'm just modifying the scope 1, just for illustration. And when we go back to the composing element, we can see that all these elements are summed here, and in the composition on part, we have the total amount. We can see what are those elements. So it's these elements that are amount for the biggest part, the second component, which is an hardware element, and the third one, which is a software. So we have the icon here to indicate which part of the element here. So we see that we didn't have to report back and rewrite the value.